Greetings all. This is the first in several videos on the subject of vector fields for Calculus 3, and it will become apparent that I'm not quite experienced at this yet, but you got to start by trying before you get better at it. So this first little example is mostly just a reminder about some notations. So we have a function of x and y equals 2x squared y to the fourth plus e to the 5x. The gradient of a function is noted with this symbol called del, and del f of xy is a vector that's made up of each of the possible partial derivatives. So there's two variables, we got x and y, so we're going to have an x partial derivative and a y partial derivative that we're going to calculate. So the x partial derivative is going to be 2x y to the fourth plus 5 times e to the 5x, and then the y partial derivative is 4x squared y to the third. So we make a vector. This particular vector has two variables, and the x component of the vector is here and the y component is here. Now we just recently learned in the chapter that this is also called a vector field. So the vector field, for reasons that will become a little bit more apparent in later lectures, we'll use the capital F of xy since there's two possible variables. F of xy equals 2x y to the fourth plus 5e to the 5x. That's the first component, and the second component is your 4x squared y to the third. So this vector, which is a gradient, is also something called a vector field. Dual names, depending on the need for it, we might use one named the gradient or the other named the vector field. Remember, graphing a vector field is quite tedious. If you wanted to graph the vector field at a particular point, such as, what's the vector look like at the coordinates 0, 1, we would be starting right here on the graph, 1 unit up, and we would actually plot the x is 0 and the y is 1 into this vector. And if x is 0, the first component of this vector is actually going to be 5. Doesn't matter that y is 1 because this term here is multiplied by x, which is 0. And then the second component of this vector is actually going to be 0, so it's not going to have an a up or down component at all. And if I were to try to draw this vector 5, 0, it would be here. We go horizontally, whatever 5 units to the right is. And if you wanted to see more vectors in this field, you'd be plotting for individual x and y points, and it would take you quite a long time to do that. So this is just a quick visual reminder. We're mostly interested for the short future in these vector fields and some special properties of vector fields that will become very important as we proceed through the chapter. So there it is, first example.